My guess is that they actually put a sentinel value in there, but we'll see in a moment. I shouldn't go through all these here. Okay. You terminate the top-down refinement process after specifying the pseudocode algorithm in sufficient detail for you to convert the pseudocode to JavaScript, then implementing the JavaScript is normally straightforward. So they pretty much gave me everything I needed. The only thing I added was telling the user what the sentinel value is. So they were pretty good. But the other thing is they told me to print it out, and they didn't tell me where to print it out. So I just used the alert box. So that pseudocode probably needed a little bit of a tweak or two, but otherwise it was pretty good. So yeah, and I would agree with this here that the significant part of the work is solving the problem is developing the algorithm for the solution. Pseudocode allows anyone to develop the algorithm. Right? You can develop the algorithm in pseudocode, so you don't have to be a programmer to develop pseudocode. And then once you work through it, and even your end users and your lay people, pseudocode is simple enough and English enough like that people can follow through, especially if you have people that are fairly well educated and think logically in their current jobs. Many experienced programmers write scripts without using script level tools like pseudocode. That's true. In many cases, it's a quick fix. You just do it. Because our ultimate goal is to fix the problem, and pseudocode merely delays it. Although this approach works for simple and familiar problems, it can lead to serious errors in large, complex projects. And I would agree with that. Usually the simple, quick fix type things you don't write pseudocode for. But if you're in a large project developing stuff from scratch, pseudocode is actually a really good tool. Algorithms. Control statements may be stacked on top of each other. That's true. Okay, so let's see what we've got here. So this is what they did. They did the var total, grade total, average, total equals 0, grade counter equals 0. They prompted them here, and then look at that. They added the sentinel value of -1. They did that. They also put a default value of 0, but that wasn't in the pseudocode. So sometimes you get the pseudocode, and when you're translating it, you realize that you really need to add this part, or it's not going to work, or it's going to be confusing, or something, and that's okay. If it's something minor, like adding a default value or adding just some text to tell people how to quit, you probably don't need to go back to the author of the pseudocode and say, is this okay to do? If it's something more major, you probably do. So the rest of this is pretty much the same that I did. The only thing they added again was the text for the sentinel value and a default of 0, which was not in the pseudocode. Otherwise, pretty much the same. Hal, yes, I could have done that, but that's not what the pseudocode said to do. So, yes, you're right. I could have done a lot of things, but I'm just showing you how to do an exact translation from the pseudocode to real code. And since the pseudocode didn't tell me to do that, I didn't do it. Control structures may be nested inside of one another. We've already seen that example with the if statement. And so here's another one that we're going to do. Initialize. So you've got some information in here. This shows an if statement inside of that. And again, we can come in and just follow the pseudocode. Initialize passes to 0. And initialize failures to 0. This is tough. Students to 0. Then it says while the student counter is less than or equal to 10, so we're back to that. Okay, so while students is less than or equal to 10, input the next exam grade. So we have to input the next exam grade to take this. that. Enter a grade. Get rid of that. If student passed, of course, now they don't give us the definition of what is a student passed. So I don't know what it means student passed. So in this particular case, you're going to either have to make an assumption, which is probably not a good idea, or you're going to have to go back to the author of the pseudocode and say, okay, what is the a passing grade? What is a passing grade? Okay, now I know that the passing grade is 60, so we won't go through that. Bar student equals 1. You're saying it should be, did it say 1? Oh, you're right. I'm sorry. I assumed 0. Pseudocode did say 1. So they don't tell me what a passing grade is. So in this particular case, I'd be stuck here, and I'd have to go back and say, okay, well, you said if the student passed, but how do I know that? And then they'll probably come back and say, oh, sorry, if the grade is greater than or equal to 60, then they passed. So they would have to revise their pseudocode to write in there that says, if grade greater than or equal to 0, add 1 to passes. That's what this should say. This should say, if grade greater than or equal to 60, add 1 to passes. Okay. Okay, add 1. So here we have to say passes is equal to passes plus 1, else add 1 to failures. Add 1 to the student counter, which will be this one right here. Okay. Print the number of passes. Print the number of failures. If more than 8 students passed, print bonus to instructor. Okay. Now in this particular case, I'm going to do something that's not really advisable. You put the script in the body, which you're allowed to do. The reason I'm doing that is because I'm going to use the document number of and then it says if passes is greater than 8, so if more than 8 passes, then print bonus to instructor. Oh, so that's what I gotta do. I gotta pass at least 80 of you? I gotta pass 80% of you to get a bonus? They never told me that before. Okay, so that's the pseudocode exactly. Now let's see, there may be more on the next page. The rest out here. Here it actually is their actual code. Alright, so they're creating the variables. They use slightly different variables, but they didn't really tell me which one, what to call it. So, and they're doing something similar for 1. Oh, that's interesting. This is here. If result equals 1, how did I do it? Oh, I'm prompting for a grade. What does the pseudocode say? Did I misread the pseudocode? Input the next exam. Oh, next exam result. Okay, so I did get it wrong. Of course, they don't really tell you. So the pseudocode doesn't really tell you that it's a 1 for a... See, next result, which is a pass or a fail. They don't really tell you that your options are pass or fail. Couldn't there be other results, like retake the test? So in this particular case, I would say there's several problems with this pseudocode and ask for more details. So, and assuming I get those details back, so maybe we call this result as well. Enter result. And eventually back and forth, I would find out from them that 1 equals pass, 2 equals fails. Eventually, I'd get that back and forth. But I didn't get that from the initial pseudocode. So this one would have to go back to them and say, you guys need to do a better job. In this particular case now, if the pass, we're saying 1 equals a pass, right? So if result equals 1, it's a pass. Okay. So I would give that pseudocode a B minus because they just did not give enough details. I'd have had to go back to them several times on that. Okay. They're going to show you theirs, and I'll go and do mine as well. So I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 for failures. And it says right there, number of passes 9, number of failures 1, bonus to instructor. Theirs, okay, so they gave you an output. That was their output, but again, this output was not specified. The format of this output was not specified by the pseudocode. So if you're just following the pseudocode, well, the great job shouldn't have been in there, but the rest of it is fine. Definitely meets the requirement. Validate the input is correct. So in this particular case, we didn't validate that the input was correct. Prompt the user to input value again. The HTML5 self-validating tools allow you to check for formatting your data. All right, so let's look and so what they're saying, make sure you validate the data, right? So if I get the data, and I could say something like, if I wanted to see, oh well, because right now, if they enter anything other than a 1, I assume it's a failure. But if I wanted to validate it, I'd do something like this. Then I would probably have to say something like else, put up an alert box. And do a continue. I don't know if we talked about continue or not, but that would just force it to go around moving it. So if they enter an invalid value, I would give them a message saying the input was invalid and force them to go around again. So if I enter an 8, invalid input. So it goes around again, around. So that would be validating input, which we didn't, the pseudocode didn't call for validating the input. As a good programmer, though, I would probably say, well, I should probably be assuming that they wanted the input validated. So even though the pseudocode doesn't say it, if a good programming practice is that you validate input, you should do this even though the pseudocode didn't call for it. Okay, so now we're going to look at some of the shortcut operators that allow you to do some things. And one student mentioned this earlier. These are essentially operators that are shortcuts. Because certain things are so common, like accumulators, and counters that there's a shortcut way of doing it. The plus equal, minus equals, times equal, slash equal, and percent equal are types of accumulators. Actually, the plus equals an accumulator, and the others are minus equal, I guess, would be a deaccumulator, whatever that word is. But plus equal is the most common. And it translates literally to C plus equals 7. The explanation that would, in long form, would look like C equals C plus 7. Same thing with minus equal. It's just a shortcut way of doing it. So if I wanted to take advantage of some of those shortcuts, I could have said plus equals 1. And that would be the same difference if I were to do that. And it would work all the same. The numbers would still work all exactly the same. So those would be your accumulators. They've also got an increment and decrement operator, which basically is another shortcut way of saying either add 1 or subtract 1 from whatever's there. It's another shortcut. Plus plus A, for example, is the same as saying A equals A plus 1. Now you can put the increment and decrement operator on either side. There's a difference as to how they work. They basically do the same thing, and if you're doing them on their own separate line, there's no difference at all as to how they work. The explanation is that pre-increment means that first it's going to add 1 to A, and then it'll use the value for whatever it wants to use it for. The second one says first it'll use the value and then add 1 to it. So if you're doing this all on its own separate line, that means nothing. But if you're doing something where you're combining that with something else on the same line, then it does make a difference. And the minus minus is simply subtracting. Now we got one that does the increment and decrement, but quickly I'll show you this could have been done also as plus plus, for example. Where it would have worked just fine. Same failures could have been plus plus. Students plus plus. All could have been done that way. Now, in their example here, they're going to show you the examples, and let's see, I think I've got this one. Any questions before we go on to this example?